We will begin working with triangle congruence, and what we're going to talk about first is we're going to talk about the side angle side theorem, SAS. And what we want to be able to do is we want to be able to determine that isometric transformations that would determine the isometric transformations that would map one triangle onto another triangle, given that two corresponding sides of the included angle are congruent. So the included angle, so we're going to have to talk about that. And then identify the sides and angles that can be used to prove triangle congruency using side angle side. And then complete the steps to prove triangles are congruent using side angle side. So let's think about included angle. And we want to included angle. So if I have some information here, and I have A, I have C, and I have point B, the included angle is going to be angle B. Okay, angle B is going to be the included angle for segment AB and segment BC. So understanding that included angle, because when we talk about side angle side, this would be my side, this would be my angle, and this would be my other side when we start talking about congruence in the corresponding parts. So let's see here, going to included angle, got that. Rigid transformations, of course, are going to be critical here in this congruence because the angles and the segments are going to remain constant. So as we go on, so if I'm given two triangles and I'm trying to determine if we can use a rigid transformation to prove that triangle ABC is going in DEF are congruent figures. So I have triangle ABC and I have triangle DEF, triangle DEF, and I'm trying to figure out, are they congruent, and can we prove it? And we can prove that the two triangles are congruent by rigid transformation because the rigid transformations preserve our angle and side length. Okay, well, I do have orientation here. So I have this included angle. D is my included angle here, and A is my included angle on the other triangle. And if we notice my two legs, the two legs that I have are going to be, we have this side here, DF, and then we have side AC, which seem to be corresponding sides, and then we have side AB, which corresponds to side DE. So we could say that by the looks of it, that given that information, that angle, we have angle CAB, and then we have angle EDF, they seem to be congruent. We have AB, and then we have, segment AB is going to be congruent to segment DE, and then we have segment AC, which is going to be congruent to DF. So we can end up using that transformation or that mapping, right? We're going to map point A back to point D, and then point C, oops, didn't mean to do that, and then point C is going to map to point F, and then of course point B is going to map to point E. So we're using that mapping. So the side angle side congruency theorem states that if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two angles the two triangles are going to be congruent. So, it's very hard for me to draw things to scale because we're human, of course, and we're not perfect. So trying to repeat a perfect item is difficult. But if I have some markings and understanding that, that's the big thing, is that's why we include these markings, is so we can go back and identify, because most of the information that we do is not going to be drawn to scale. So looking at this, these two triangles, I have, looks like I have triangle ABC is going to be congruent to triangle DEF. Let's see here. So just breaking it apart, looks like segment AB is right here, and segment DE is right here, so those are congruent. If I look at segment BC is going to be, well, BC is not identified on here, so let's go with, how about segment AC, right? AC, got that right here, and then segment DF, got that right here, okay? And then my included angle, well, my included angle is going to be angle D, right here. So here's my included angle, and then my included angle is going to be A. So it looks like, there we go, we have two sides and the included angle are congruent, therefore these two triangles are going to be congruent. Okay, so given the diagram here, it says that if segment CB bisects angle ACD, what additional information can we prove? All right, so let's see here. It's telling me that angle CB, right there, is going to bisect my larger angle of ACD. All right, so if that's the case, if it bisects, we know that it cuts that angle in half. So those two angles are going to be identical in length. Let's see, what else can we determine? I know then that, looking at that angle ACB is going to be congruent to angle DCB. I know that, well, I know that segment CB is equal to segment CB, right? It's congruent to itself. Let's see, what else can I determine? If see this, if this angle and this angle are congruent, I believe we have an isosceles triangle here, so we're looking at 52 centimeters here. So 52 centimeters, and we have a base here, so AD is going to be the base of my isosceles triangle. And I'm trying to think, what else can I prove? Well, the measurement of ABC should be equal to 125 degrees, and then segment AB should be congruent to segment DB. Okay, those are congruent. So I know that this side is congruent to this side. I know that this side is congruent to itself, and I know that this angle is congruent to this angle. I know that this segment is congruent to this segment, and this angle is congruent to this angle. So if that's the case, I should be able to prove then that triangle ABC is going to be congruent to triangle DBC. So ABC is going to be congruent to DBC. We do have side angle side. Heck, we have side angle side. We also have side angle side. So we're able to use many different methods here once we start filling in all the information. So moving on, and we will talk about, the side angle side triangle congruency, and being able to determine that those determine the isometric transformations that would map one triangle onto another, given that the two corresponding sides of the included angles are congruent. We want to identify the sides and angles that can be used to prove that congruency, and then completing the steps to prove those. So using side angle side will allow us to bring some added value to our geometric problems that we're working on.